Hey everybody and welcome back. My name's MrCaproni and this is AP Statistics. Today we're going to be covering displays of categorical data. Now what does that break down into? That's going to be covering frequency charts, relative frequency charts, pie charts, bar graphs, and a little thing called the area principle. So stay tuned. I hope you're going to learn something new, and thanks for joining me in this video on AP Statistics. So starting off, let's look at the 3 rules of data analysis. Now your textbook puts a ton of emphasis on these, and it's easy to remember because all 3 of them are the same. Make a picture, and make a picture. Now, the reason for this is because a lot of times just looking at a list of numbers is not very helpful. That goes for you and anyone you're explaining it to. If I give you a list of 50 numbers, you're going to be able to hear them, yeah, but you're not going to be able to get a lot of information out of them. But when you put them all together in one picture, it kind of gives you a big picture understanding of what's going on. Not only that, but you're going to be able to see certain patterns that you may have not been able to see with a list of numbers, and you'll be able to make some observations that otherwise would be lacking. At the same time, when you are relaying this information to other people, it's incredibly important to have a picture because that's how they're going to best understand what you're saying. Again, if you're not going to be able to understand a list of numbers, why would they? So when you are creating your pictures, you want to choose something that will relay your information and the point you're trying to show to the best of your ability in a picture, because that is how they're going to understand what you're trying to get at. So how do we compile the data in a way that will make it easy for us to create a picture? Well, I'm really happy you asked because the first way we're going to do that is by using frequency tables. Now, the data we're dealing with today is all going to be categorical data. Remember what that means. It means this is all data we're collecting that is more like a label, not a collection of numbers. Now, at the same time, when we are dealing with pictures or things that we're representing, usually numbers are involved. So where do we get those from? Well, a frequency table compiles all the data and tells us how many people chose each option from whatever it was that we were observing. Or for example, if I were counting the color of cars, then a frequency table would tell me how many of each color I got. So let's look at what we got here. A lot of today's stuff is going to be dealing with the Titanic and how many people there were on the Titanic and how many of them died or lived, survived, whatever you want to call it. We're looking at here, we got class. What is a class? That's the level of money or influence the people had that were on the boat. So first class is your super rich people, second class, pretty rich people, and third class is going to be your mediocre rich people. Why did I label them all as rich? Because they were on the Titanic, so they at least had some money no matter what. The crew are all the people who were working on there. Now, what are the counts in this case? As you can see on the right-hand side of the chart, the count is how many of each of those people they had. So there were 325 first-class passengers. So that is what a frequency does. First off, it gives us all of our possible options, first, second, third, and crew. And then on the other side of the chart, it gives us how many of each of those options there were. The second type of table we're looking at is the relative frequency table. Don't freak out though, because it's almost the exact same as the frequency table. Here's the difference. Whereas the frequency table gave us how many people fell into each category, the relative frequency will go ahead and total up all those people and tell you what percent fell into each category. Now, what does that mean for us? Well, if we look at the first class where it says 14.77%, this is the same as the 325 number we just saw. Here's the difference. Before we said 325 people fell into the first class category. Now we're saying 14.77% of everyone fell into the first class. So a lot of times we look at this as the same because really they're describing the same information. And if we look at it in a picture, which we'll see later, you'll see that they actually even look the same. Both of them are describing what we call the same distribution. Now, what the heck is a distribution? A distribution is just a fancy way of talking about our data as big picture. A distribution is how did the numbers fall? How did we end up when we're looking at everything all together? That's your distribution. We'll have some special names to describe that distribution as we get further in this course. But for right now, just know that's kind of the big picture of our data. So We have two tables to work with here, a regular frequency table and a relative frequency table. Both of them are giving us similar information, but one gives us the total count of people and the other one gives us the percent of the total. All right, so here's our first visual. Let's take a look-see at it. What do you notice? What do you wonder? I hope you notice that it's terrible. Why is it terrible? I don't know. Why don't you go ahead and pause the video here and leave a comment down below on why you think this is a terrible graph. Now, with that said, let's go ahead and start discussing some of the things that are wrong here, all right? There is one major thing that I'm trying to hint at that we're going to get into, but that comes from this. If you're looking at this picture, it looks like a huge amount of this boat is the crew. Now, although the crew is the largest category we have, it is not as large as it seems. So why? What happened? What went wrong? Well, what's going wrong here is actually referred to as the area principle. Now, what is the area principle? It essentially says that when you're looking at a graph, the area of the visual should correspond with the actual percent that it is of all of your categories. In this case, it looked, let's go ahead and go back and look at that. It looked like this was huge, all right? But why was that? Well, remember, when you find the area of something, you're multiplying the length times the width. So that means that you are actually almost doubling or squaring the area of this guy by creating a picture instead of just a bar, which is where our giant issue is coming in. So even though it only goes a little bit further, because of the width of it changing as well, it makes it look huge. As you can see up here versus some of the ones down here, this thing looks ginormous. So the area principle is here to help us see that, hey, you can't just use whatever picture you want to represent this situation. It needs to correspond to the correct size of the value it represents. So how about we take a look at how this is done right? Here's a bar chart here of the same information we saw with the ships. Now, does it look as beautiful and pretty? No, but it's right. And I'd rather be right than beautiful or pretty. Luckily, I don't have to choose though, because I'm both. So, as you see across the bottom, they have included all of the different options we had for class. Those are our variables. Next, we have across the left-hand side, frequency, which is just how many people fell into each of our categories below. So this, again, is the most commonly used. They do usually put space between the bars so you can easily see which category each bar stands for. Is it wrong if the bars are touching? No. They're allowed to touch. It's just usually so that people can see it a bit more clear. They will put some space between them. Now, with that said, we also have a relative frequency bar chart, which is just like our frequency table versus relative frequency table. If you notice, these two bar graphs look exactly the same. The only thing that changes is the left-hand side. Instead of having the number of people that fell into each category, it has the percent of people that fell into each category. But at the end of the day, a relative frequency bar chart is going to look the exact same as our regular bar chart. The only thing that changes is the numbers across the left-hand side. When dealing with percentages, you can also use a pie chart. Now, it's very similar to the relative frequency bar chart because it still is focused around what percent of the whole picture we're dealing with. But with a relative frequency bar chart, you're really just comparing the percentages to each other. In a pie chart, you can actually see how that fits as a part of the larger picture because each slice of the pie takes up the exact percent of the whole circle as that category does from your people. So it can be very helpful to use a pie chart instead of looking at a bar chart in that case. So remember, at the end of the day, listing off numbers is not going to be a good way to grab someone's attention, and it's not going to help them understand anything. When we're dealing with categorical data, we want to resort to using different types of charts to help people understand the information we're presenting. In particular, we've looked at bar charts, relative frequency bar charts, and pie charts today. On top of that, you can organize the data for those charts by using a frequency table or relative frequency table, depending on which one you want to do, percents or your actual numbers. All of this is super helpful and very important for what we're doing for the rest of this class. Well, that's going to be a wrap for today. So thanks for joining me. I hope you guys learned something new. If you did, go ahead and click the like button below. And remember, if you want more AP statistic videos like this, go ahead and hit subscribe and you'll get my new videos each week. Again, thanks for joining me. I hope you have a fantastic day.